Dream to become the next Sir Isaac Newton or Albert Einstein?
Learn physics from Rashid Al-Bari. Let's start today's remote learning with Do Now.
Let's consider hydrogen atom. Let's draw the Bohr model of hydrogen atom. What do you have in the hydrogen atom? You have an electron and you have a proton. Electron has a charge negative 1.6 times 10 raised to negative 19 Coulomb, and proton also have a charge which is same in magnitude but different in direction. So this is negative, this is positive, but the magnitude are the same. There is a distance between these two charges, and that is 0.53 times 10 raised to negative 10 meters. All right. So about 1780, Charles Coulomb discovered that there is a force between these two charges. All right. Now let's ask you a simple question. The charges, we got the idea of charges because charges discovered by, who discovered the charges? Franklin, 1751. Franklin discovered charges, 1751. 28 years later, Coulomb discovered that there are forces between two charges. That's good. Now, what can you do using this information? Very simple. I'm going to ask you a do now question, and that is number one. Can you create charges? Number one. Can you create atom? Number two. If you can create charges, can you create this much charges? How much is it? Can you create negative 1.6 or positive 1.6 times 10 times 10 raised to negative 19 Coulomb? Can you create that much charges? Number three. What can you do by that charge? Well, let's answer this two question first. Yes. Yes, in fact, yes. In fact, you can create more charges. More than that. Next question is how much charge you can create by using Coulomb and the here. When you rub the Coulomb against your here, how much charge you can create? By combing your here. In fact, oh yeah, that's the answer I'm not going to give you. You're going to have to approximate how much charges you can create. Now pause the video and then try yourself.
Now pause the video and try your own.
Now yeah, you can exactly create 1 microcoulomb, which is more than that. How do you know more than that? By converting this one to SI unit, which is Coulomb. 1 times 10 raised to negative 6 Coulomb. So this is more than that. Now, what can you do? You can create charges by using Coulomb and here. That's good. But what can you do? What can you do by these charges? What? Number 4. What can you do with these charges? You can pick up a piece of paper by using the Coulomb. You can pick pieces of paper easily by using that 1 Coulomb charges. So I'm going to create charges at home. So I'm rubbing more. That means I'm creating the maximum of 1 Coulomb. You'll never be able to create more than 1 Coulomb of charge by rubbing the Coulomb with your here. See, this is the evidence of charges, and this is what you can do by charge. We know that Franklin discovered charges in 1752. That's what he did. He discovered charges. And force discovered by this guy discovered charges. Whatever force. In fact, the gravitational force. Gravitational force discovered by Sir Isaac Newton, 1665. Newton. 1665. In fact, 1665 was the year the London affected by plague. So the Great Plague of London. During that time, he discovered the force of gravity. And then the Coulomb. Charles Coulomb. 1780. Franklin is American, British, and French. So he was born in America, he was born in England, and he was born in France. Okay, now let's focus on what did Newton do. Newton said that if you have two mass 1, mass 2, then there would be attractive force between these two mass, given the distance r. If you separate these two mass r distance away from each other, then there would be force. And this is what he wrote: G m1 m2 over r squared. What are the SI unit? SI unit. So SI unit for G is you have Newton, meter square, kilogram square. What is the SI unit for? Mass 1? Kilogram. What is the SI unit for mass 2? Kilogram. What is the SI unit for r, distance? This r is meter, so r square is meter square. So meter square cancel, kilogram square cancel, you're left with Newton. Yes, the SI unit for gravitational force is Newton. About 115 years later, the French guy used the British guy's idea. And then, what did the idea? That he said that there is an electric force between these two. Okay? Between any two charges. So this charge is, this is the charge, and this is the electron. And there is a force between these charges. Okay? So what the formula did he write to calculate the forces? He wrote almost exactly the same formula. If you look at this formula, you will notice that the both formula are almost the same. So this is Fg, and he wrote Fe, electric force, is equal to, this is Newton constant, he wrote Coulomb constant. This is the mass, but this is the charge, so charge, and this is the another charge, and there is a distance between these two.